That's what I have not.
Okay.
Is that an ice machine?
Products of reactions. There's a start.
Yeah.
Does it work?
It does. I don't have it plugged in right now.
Do you use it then?
Okay.
I can, but like tomorrow.
Is it good ice?
Yeah.
OH ions.
Like the little
It's
Sonic?
square, like half a
No,
minute.
not
Oh.
Borg, if I predict what you had for Tanner, I give 1 point extra credit.
Yes,
No way.
correct.
Please?
Oh, I know what you're talking about using time.
Okay.
I'm gonna bet you
So-
McDonald's.
Remember, when you're dealing with solubility, it's solubility, which means something has to dissolve. You have a small Ka value of 1.8 times 10 to the minus 11. Why is the Ka so small?
KSP.
No, or KSP. Why is the KSP so small?
It's not going to dissolve.
It's not favored in the forward direction. So, here's what's happening. Do not focus on the solid magnesium hydroxide. Focus on the fact that it's going to produce some magnesium ions and how many hydroxides.
Wait, and that's because it's a weak acid.
No. This has nothing to do with acid base.
Okay, so
Absolutely nothing
Stop
to do with
making fun
acid
of
base.
her every
I'm not making fun of
yeah,
anyone.
shut up, Nathan.
Bro.
Nathan,
Nathan,
I'm here trying to
Go home,
learn.
bro. Go
Okay.
home. Go home.
Hey,
You go home.
Coming
Can
from
I
the guy who
teach-
said non-necessary.
you keep your mouth shut.
What are you doing?
Oh, I know
You
better
turn
than
to
that.
Shannon or
Wait, can we just notice how once again the middle of the room is
Stay out of this.
Okay, can I stop getting blamed?
And,
That was
and
all it
notice
is.
that this middle of
It's
the
all
room
this
is
guy.
trying to mediate those two sides of the room.
I'm just saying.
It's
like,
all- it's
there's
all
a
right.
provision.
Waylon's fine.
Okay, guys,
I'm fine.
just. I'm sorry. Please, let's just focus.
We are helpless.
And let's stop going paper airplanes
This
for
is
not locking
Nathan's
Mark.
world we're living in, alright?
Bro, stop saying stupid stuff.
She gave me ammo.
We are helpless
Okay.
if he doesn't show us.
Back to our story. I want to go home at some point tonight. So you have some magnesium hydroxide. It's going to dissolve and produce some magnesium ions and some hydroxide ions. True?
Sure.
Okay. This is not an acid-based problem. This is just an ionization problem. So you know what the KSP equals, which is 1.8 times 10 to the negative 11. Any units?
No.
No,
K
because it's a
values don't have
KSP
units.
value. Okay? Now, mathematically, what do you multiply together to get that KSP value?
Magnesium times OH, concentration of magnesium times
Concentration of my
Squared.
magnesium ions times the concentration of my hydroxide ions
Squared.
squared. True? True? So, the reason that we write it like this is because it's products over reactants. But the reactant is a solid. You can't talk about the concentration of the solid magnesium hydroxide. It just doesn't make any sense. But you can talk about the concentration of the ions.
Let's start.
Now, here's the story. Some of this is going to dissolve. I'm going to let that be X. So how much hydroxide am I going to get? 2X. Right.
You are.
4x cubed.
Yeah.
So this becomes X times
2x squared.
2X squared.
Oh, wow. I made it somewhere. I found X.
Do they get partial?
So this becomes 4X cubed. True?
True.
So if you solve for X, what do you get?
1.65 e to the negative 4.
1.65 times 10 to the negative 4th. Right? Okay. That gives you two numbers. It gives you how many magnesium ions there were, but it also tells you how much of the MgOH2 had to dissolve to get that amount of magnesium.
You're so smart, Bird.
All right, Louise. So, you get this, but what units is this in?
Polarity.
Molarity, which is what? 10 to the negative 4th.
Most liter.
Moles per 1 liter. Do you have an entire liter of this stuff?
No, we have 100 milliliters.
You only have 100 milliliters. And what do you want the units to be in?
Grams.
Grams. So, come down here, 1 mole to save you some hassle That's 58.32 grams of magnesium hydroxide. And then your last step is to multiply by the volume. And you do all of this, and you get 9.6 times 10 to the negative fourth
I got there eventually.
grams of magnesium hydroxide. That's why I said when you had 10 to the negative 10th, I was like, you're only off by a million.
Yeah, it was rough.
It was rough.
Rough start.
It was rough. Rough start. Rough start.
I don't know how you start.
Now, they didn't ask you this, but I'm going to throw a little wrinkle in on this problem. What would happen if I added some hydrochloric acid? What would happen to the concentration of the hydroxide ion?
I think it would go. Actually, I'm not going to speak.
Down?
Just kidding.
Wait.
No,
I think it would go down. I think
Why?
it would go down. Because
Wait,
the H from the HCl and the OH would bond together, I think. So,
Oh, you're
for H2O. Yes, thank
So
thank
you would decrease
I
the
think it's the
concentration
whole
of the
thing.
hydroxide ions.
True.
So if there was some precipitate, what would happen?
The bank.
The bank, that's the bank. The bank would
Bank
dissolve
is
to replenish the hydroxide ions that were being taken up by making the water.
Thank you. I got one thing right.
You did. Now, what if the anion had been the conjugate base off a weak acid? Like, let's say it had been, I don't know, acetate, just for the sake of argument. Okay? If the conjugate base in this situation had been a weak acid, and I added hydronium ions to it, what would happen?
They would combine.
They would combine and you'd have the exact same effect.
Yeah.
Okay? But what if the conjugate base was chloride ions and I added hydronium ions?
They wouldn't.
Nothing would happen.
Because they're
Why?
strong
Because
acids.
this is
so
not
they
going to
don't want
bond
to
together.
bond
Okay?
Mm.
Oh, that's nice. All right. Now, we haven't talked about lattice energy, but we will like tomorrow. So you get a little bit of a head start on tomorrow's lecture. So lattice energy is basically how much energy you have to put to break something apart. Okay? As a lattice. Lattice means that they're bound together. So what they're giving you is the lattice energy of magnesium hydroxide versus the lattice energy of strontium hydroxide. Especially for those of you that are in AP chemistry, you need to answer it in terms of this equation right
Are we
here.
all in?
You mean physics?
No.
Or excuse me, AP physics.
He gets some mixed up. It's been a while.
So,
That's the
what does this equation give you?
Force.
Force between
The
Two
two
particles.
between two charged particles.
Wait. So
Right?
per-
So, why? Here's the question: why is the lattice energy of magnesium hydroxide bigger than the lattice energy of strontium hydroxide?
You gotta look at the
This.
periodic table.
D
Yeah.
is smaller.
Yeah.
Which one has the smaller radius?
The one.
Magnesium.
Yeah.
Magnesium does. So those are packed more tightly.
Greater force.
So the coulombic forces are stronger, so it takes more energy to break them apart.
Bang.
Right?
Explain.
All right.
Wait, that was you said the magnesium? was?
Yeah, because the magnesiums are closer, and because you're dividing by a smaller distance, that has more force.
Try kitty cat. Wait, can you scroll up to the last problem after you? Yeah.
Yeah. Okay, so there's one left, that 2008. Now, that's going to deal with a hydrate, and you all have dealt with hydrates, like in that last lab that we did on enthalpy. You had hydrated copper sulfate, and then you had anhydrous. Okay? Hydrated just means that there's some water attached to it. It's not a solution. It's just, it means there's water molecules attached to it. So, try that question.